3. Well, I've got one number that's exactly 90, so that's going to make that a right triangle. So take a look at B. 46, 46, and 88. What type of triangle is that going to be? Acute, right, or obtuse? Kaylee?
Acute.
That's an acute triangle because all the numbers are less than 90 degrees. Okay, example 2 now, we're talking about the side lengths of a triangle. Side lengths. Now, when we're talking about side lengths, we're looking at the last 3 definitions there. Equilateral, isosceles, or scalene are going to be there. All right, so here's the descriptor. They tell us side A is 4 whatever units, centimeters, inches, miles, meters, doesn't matter. Side B is 7. Side C is 6. Side D is 4. Side E is 4. Side F is 2. Side A is 4. B is 7. C is 6. D is 4. E is 4. F is 2. And you're supposed to put the 3 requested sides together to identify the triangle type. 4 questions there at the bottom are ABC, triangle ABC, triangle ADF, triangle ABE, triangle DEF. Guess I'll pause again so you can catch it. Okay, so we'll start with ABC. What do we know about triangle ABC? We know that side A measures 4 whatever. Side B measures 7. And side C measures 6. Based on those 3 numbers, I'm supposed to identify if it's equilateral, isosceles, or scalene. Well, the one that says that none of the numbers are the same is scalene. So this happens to be a scalene triangle. 2 of the numbers are the same, then it's isosceles. If all of the numbers are the same, then it's equilateral. All right, so ADF. A is 4, D is 4, F is 2. So 4, 4, 2. Scalene, isosceles, equilateral. That's an isosceles triangle because 2 of the numbers happen to be the same. ADE, 4, a 4, and another 4. Scalene, isosceles, or equilateral? That's equilateral. When all 3 numbers are the same, that's an equilateral triangle. All right, the last one, DEF. D is 4, E is 4, F is 2. That makes what type of triangle? That's back to isosceles. 2 of the numbers are the same. All right. Now, the rest of the problems then, we're using drawings. This is kind of putting together the stuff we talked about triangles today and triangles making more than 180 with some of the stuff we learned yesterday. All right, we learned yesterday about supplementary angles, 2 angles that make 180. We learned about vertical angles, angles that are across from each other being the same. We learned about alternate interior and alternate exterior angles when we were dealing with parallel lines and a transversal. We learned about corresponding angles, angles in the same relative location. Also, parallel lines with the transversal. We're going to be using all that stuff in these last three examples in some way, shape, or form to help us answer these questions. Now, as you can see, 3 and 4 don't have anything to do with the parallel lines, so the corresponding and the alternate ones are out. But everything else we can use there. So example 3 there says to find A and C. This angle here in the bottom left corner of the triangle is A. Bottom right corner of the triangle is C. Now here it's left it says 126. Up here top right of the top of the triangle it says 26 degrees. All right. Well, we don't have a lot of options here. We're pretty much going to have to start with A. So let me cover that up for a minute. Now, just looking at 126 and A, what can you say that's true about 126 and A?
It's a straight angle.
Yeah, it's a straight angle when you put them together. So these two together have to make 180. Right? Well, we already know that this here is 126. So I can 180 minus 126. 180 minus 126 is 54 degrees. So A is 54 degrees. Now, I needed to do that one first because there's no way I could have gotten C. Because you notice I've got 3 angles there inside a triangle. We know that these 3 together have to make 180. Well, here then that means I have to have 2 of the numbers, otherwise I'm not going to be able to find the third. So once I found A, now I've got the 2 numbers I need. So these 3 together make a triangle. So to find C, I've got to do 180 minus 54 minus 26, and that means C is 100 degrees. All right, example 4 says to find a missing angle. Top angle says x plus 3 as an x plus 3 degrees. Bottom right angle says 2x. Those are the 2 we're going to find. This angle down there doesn't have an angle measure on it, but it's got that upside down and backwards L on it, which we talked about yesterday. That means right angle. So we know that that one has to measure 90 degrees. So that's a dead giveaway. The other 2 we're going to have to work on. All right, now, we know a triangle, again, makes 180. We know that this angle down here makes 90 all by itself. So if a triangle makes 180, and I've already accounted for 90, how much do I have left? I have 90 left. So we know that this angle and this angle together make 90 degrees. So x plus 3 plus 2x makes 90. And surprise, surprise, we come back to solving equations once again. You can see the equation I'm solving is x plus 3 plus 2x equals 90. I added those 2 things together, set them equal to 90. All right. So we simplify a little bit here. X plus 2x makes 3x.